Alright, in the previous video we did things like find sine of 7 pi over 4 and cosine of 7 pi over 4 and so on. In this video we're going to talk about reversing the situation. So what about if you had to do something like find all angles theta inside a certain interval? Let's just say 0 to 2 pi, where sine of theta is equal to a half. Then you should there are several ways to do this, and perhaps the easiest way is by using the unit circle. But from here you can, well, where is sine of theta equal to a half? Well, that's asking, where's the y-coordinate? Where's the y-coordinate on the unit circle equal to a half? Well, there's a half as the y value on the y-axis, and what points on the unit circle have a y value of a half? Well, there's one right there, and there's one right there. So straight away what we're seeing is that there's going to be two solutions. I've only highlighted the point so far, but really there's this angle right here that we're looking for. That's one of the angles. And the only other angle that's between 0 and 2 pi radians that we're looking for is the one right here. So if I were to label that, that looks like this. And this is where, practicing is good. You'll have sort of this recognition from having done enough problems the other way, the forward way, answering things like, what is sine of pi over 6? What is sine of pi over 4, and so on. But here, if you have 1/2, now recall that this is a y value, and 1/2, which is, by the way, if you would like to write this is root 1 over 2. That's the smallest y value of these three. Okay, so I just drew the 3 points, and you can kind of reason for yourself that it was correct to draw these 2 points above, not below, okay, because there's the y value of root 1 over 2, then the bigger root 2 over 2, and finally the biggest y value is right here with root 3 over 2. So here we can, if you don't need to really label this right now, but there's a root 3 over 2, biggest x value, smallest y value. So this is one of the angles we're looking for. This is a 30-degree angle. It's the smallest of these three special angles, or pi over 6 radians. And then finally the other angle you can get using, you can use reference angles to say, well, there was this angle, and then this angle has to be the same size angle. So to get this bigger angle right here, we should actually be doing 180 degrees, but then minus this smaller angle, or if we said this on radians, pi radians minus this pi over 6. So this angle right there is actually going to be pi minus pi over 6, which is 5 pi over 6. And the more you become familiar with navigating the unit circle like we've talked about in the previous 2 videos, the faster you'll be at problems like this. Let's look at one more actually in this video. Let's take a look at cosine of theta equaling negative a half. So same idea, but in the unit circle. Now what we're trying to do is we're trying to find places where the x-coordinate is equal to negative a half. And there's one right up here. And then there's another angle, well, a point corresponding to an angle down there. So we're looking for an angle somewhere in the second quadrant, and then this quite a bit bigger angle in the third quadrant. And you can do the same sort of thing here. A negative a half, well, that's the one that's closest to the x-axis. There's these 2 more. If you want to, instead of thinking of this over here where the negatives sort of make things weird, you could first take this point and flip this into the first quadrant. And if you had an x-coordinate, cosine is the x value, cosine of theta is the x value, x-coordinate of a half, well then there's the bigger x value, and then there's an even bigger x value. Okay, so you can see right here that this is a 60-degree angle, or a pi over 3 radian angle, and this other angle right here actually has the same reference angle as this angle right there. So this angle that we're looking for is theta is pi minus pi over 3, or 2 pi over 3. And finally this angle in the third quadrant is, well, this is pi plus a remaining additional pi over 3. So the angle right there is actually theta is equal to 4 pi over 3. So there are actually 2 solutions to this equation, as long as you're only looking for thetas, which are between 0 and 2 pi.